dear colleagues, dear visitors, dear young participants. It's my great pleasure to announce the subject of this research work that has been carried out at our university in the collaboration with scientists from the United Kingdom and from the Don State Technical University from Russia. In the collaborative research, this concerned with new electromechanical properties of modern composite materials. The next, please. As you know, composite materials are a heterogeneous system that consists of two or more components, and different factors would influence the effective electromechanical properties. In the center of the attention, we have the functional composites with the remarkable piezoelectric properties, and these properties can be varied due to new effects, so-called orientational effects. In the context of the orientational effects, we can vary the anisotropy of piezoelectrical properties, the anisotropy of dielectric and elastic properties, and this subject in such a context, in such a complex, is attractive for many applications. For example, for a hydrostatic application. The next, of course, the new direction is associated with the use of modern materials. The very prominent class of modern piezoelectric materials are relaxor ferroelectric solid solutions, single crystals based on lead titanate and, for example, lead magnetic, or lead zinc-navate, lead indenavate, and related perovskite type single crystals. These crystals are grown and polished on the specific directions in order to provide the high piezoelectric activity. We try to show a perspectiveness of use of these single crystals in order to obtain optimum properties, in order to obtain maxima or minima or other extreme characteristics of new composite materials with these highly effective components. In the center of our attention are composites of the conductivity 2, 2, and 1, 3, based on relaxor ferroelectric solid solutions. But it has been a very long prehistory. I recall the start of the new millennium. I recall the start of this century and my interest in heterogeneous ferroelectric solid solutions. For example, solid solution and ceramic system based on this solid solution. This example is associated with a paper on the performance of the electromechanical performance of the 1-3 type composite based on conventional ferroelectric ceramic. For example, high values of the figure of merit, the smart figure of merit, was a stimulus to continue this research and to find more optimal interrelation between the properties of compounds. For example, the next. The second item of this research at the start of the new millennium, it's the problem of the heterogeneous solid solutions of the perovskite type, the problem of the coexistence of phase, the problem of the internal mechanical stress, and new possibilities to form as a heterophase systems. Please, the next. The next stimulus was a paper concerned with orientation effects in this new single crystal, like P.N.N. PT near the morphotropic phase boundary. This single crystal is of interest. Is also in the single domain state, and the piezoelectric properties, for example, piezoelectric coefficients D, E, H, and electromechanical complex factor R, okay, can be varied in wide range due to the orientation of the spontaneous polarization vector. Creating the specific on the rotation, specific cuts of the single crystal, we can vary the piezoelectric coefficients and related characteristics in order to provide optimum of the properties in the related composites. And this idea was in the center of our attention hereafter. Please, hereafter. So we studied different piezoactive composites. For example, for ferroelectric relaxor single crystal polymer, and three different orientations of the main crystallographic axis, three different polling directions have been chosen. Please have been chosen. It is the conventional schematic of the two components composites, and we have paid the great attention to 1-3 system, to the 2-3 system in different orientation, and to 1-3 system. These three connectivity patterns are common on interest, are common for different applications, including hydrophone, hydrostatic application, and we worked with this system. For example, as a diagram from our papers that has been cited more 10 times in different works, and this diagram suggests that there are interconnection between the connectivity patterns. There is a system of so-called junction connectivity patterns, and other remaining connectivity patterns can be generated due to these junction patterns. And schematics and different parameters that determine the volume fraction of different components are shown in these patterns. I use different methods for evaluation of properties. It's the system of the effective electromechanical properties that are exploited in the long wave approximation. The next, please. The next one. For example, a schematic of the effective field method that's suitable for three different connectivity patterns. In this system, we represent an inclusion, a piezoactive component surrounded by the matrix, and the effective field is acting on this inclusion. This effective field is to be taken into account due to the electromechanical interaction between the components of the system in the surrounding area. For example, the next application, the matrix method, and the possibility of averaging on two orientation for the one composite. Now, this composite resembles a box with two kinds of pencils. The box of two kinds of pencils, or the chess table. The chess table is from the top. We see from the top different fields, black and white, like in 1-1. And in this case, we have found the different variants of volume fractions with two parameters, and we compared with the finite element method date. Please. So, of course, there is an interesting study of different effects in composites with piezoelectric components. There are three main effects in composites. For example, the sum effect, the combination effect, and there is also the effect of the generation of the new properties. In our study, we have mainly context to the effect of the combination of the properties, for example, dielectric and piezoelectric, dielectric and elastic, and etc. Please. The system of effective parameters, effective hydrostatic parameters to be studied are listed here. We show an example of the one-three composite and the orientation of the coordinate system. Please, the next. And there are different experimental data to be taken into account. On the right side, we have a list of ceramics, of the piezoelectric ceramics of the perovskite type, the conventional ceramics, yes? And there are modern single crystal materials with the prominent piezoelectric properties, including the piezoelectric coefficients D31, D33, D15. No, we have an advantage, an obvious advantage, and these advantages helps us to show the more high parameters, effective parameters in the composite structure. So, for example, the full set of the electromechanical properties for the 0, 1, 1 pole single crystal with two domain types. The next one. It's the application of the date, for example, use of the matrix method and data from the firmware slide to the two single crystal polymer composite, and we show the orientation effect the various orientation of the main crystallographic axis of the single crystal, and we have shown some preference. For example, in this range, as the moderate volume fractions of the single crystal. The next, please. It's the system of the data on the related composite and different orientation of the remanent polarization vector in the matter, in the second component, in the polymer components. It's also the orientation effect, and this effect is to be taken into account at the prediction of the performance. And as we understand from our studies, the DH, the hydrostatic piezoelectric coefficients, depends on the combination, is due to the strong combination of the piezoelectric and elastic properties. At the same time, the GH piezoelectric coefficient, hydrostatic piezoelectric coefficients, is due to the combination of the piezoelectric and dielectric properties, especially as the small volume fractions. And the configurations are different due to different modes of this combination. The squared figure of merit is of interest. No, we reached the large values due to the strong combination of the piezoelectric and dielectric properties. No, the next example of electromechanical properties. No, we compare the same single crystal, single domain and pole domain. And this PVD for the ferroelectric polymer with a known set of electromechanical properties. And these data have been analyzed in the context of the two composites. For the single domain PVD composite, we have shown some very large values of the piezoelectric coefficients EH, hydrostatic piezoelectric EH, and no analogs in the literature. Usually, for conventional ceramics for different single crystals, the value of EH was not more than 15 coulomb per square meter. We have shown possibility for the largest values as high as 3 times more. And this maximum has been analyzed on the next list. This maximum has been analyzed, and this maximum has been associated with a synergetical combination of maxima of different piezoelectric coefficients like E33, E32, and E31. The next example is a similar composite with based on p-min 28% PT, and there are 3 different sets of electromechanical constants for 3 different orientations of the Bauэн filter. Please. We have shown different variants of the rotation mode of the spontaneous polarization in order to preserve the high piezoelectric activity, please, in this composite. And the similar effect, the similar synergetic effect, as we reach maxima of 2 or 3 different piezoelectric coefficients, and the positive contribution into the hydrostatic piezoelectric coefficients. So here we have the comparison. We have the comparison of the hydrostatic parameters. The similar composite with some layers pulled along 0, 0, 1 or 0, 1, 1. Either this orientation or this orientation of the crystallographic axis. And the performance is different. We have shown the values of absolute maximum, and we have the obvious advantage at such the orientation of the main crystallographic axis. This slide suggests there is an additional stimulus to increase the high values of the piezoelectric properties of the hydrostatic parameters if as we use the so-called oxatic polymer, with a negative Poisson ratio. Varying the elastic properties in the Poisson ratio, we reach the higher values of QH, for example, squared figure of Mayer, due to the positive balance of piezoelectric coefficients like D33, D32, and D31. We have the very strong combination effect. It's the effect of the combination of the piezoelectric and elastic properties. For example, okay, and now please continue, isn't it? 1 minute. For example, this diagram and the schematic of our study. The next, the result on 1, 3, with a similar system of maxima and the vector combination properties. The next, for example, the similar situation with the porous matrix. The next, the date on the anisotropy factor and the electromechanical properties. The next, for example, the role of the porosity matrix. The next. And our conclusions. Due to the restricted time, I will not read the conclusion, but you see here the next. Our list of main publications and the new book to be published at Springer in October this year. The next. Thank you very much.
Dear colleagues, have you any questions to Professor Toполов?